Okay, cool. Let's get started. Hope everyone had a great lunch. I was just preparing everything because we've got a lot of live demos today, and I'm going to show you, as a developer, as an open source engineer, how to go from your containers and your local applications that you're developing on your laptop to pods to eventually Kubernetes using open source tools, and we're going to have a really fun time doing so today. But the real value I want to provide to you today is, as a developer myself, working with Kubernetes can feel kind of daunting, right? At first, you're working with essentially, infrastructure as code, these huge YAML files. We're working with a huge ecosystem in the CNCF. And I want to share with you how I build applications for Kubernetes locally and how I can build those with confidence in order to deploy them on Kubernetes environments wherever it is in the hybrid cloud. So we're going to have a fun time today, I promise. And we've actually got a lot to cover today. When I talk to developers, a lot of people don't really know that there's an open source alternative to Docker Desktop. So we're going to be playing around with this open source tool, and it's called Podman Desktop. It's an extension of the container engine Podman. But in addition to replicating the functionality of building and running containers, you actually have native Kubernetes features and integration for pods, deployments, and other resources. So it allows you to essentially run these locally without having a full Kubernetes cluster, but also to scale, so to go from my local machine and connect directly to a Kubernetes cluster. So this is really helpful, for example, if we're trying to adopt cloud native and Kubernetes technologies, because one of the biggest issues in adopting cloud native is this skills gap. You've got developers who can build and write code, but you also have the ops team who need to translate that code into a production environment. And we're going to make this a little bit easier for you today, and I'm going to show you how with some live demos. So eventually, at the end of the day, we're going to have more time for eating jamón ibérico, which is my new favorite food. As well as using WhatsApp, because we don't have this in the US, so I'm kind of getting used to this still. And of course, one of the best things is going to the greatest football team on earth, right, to see them play. Woo! And if you're a fan of football or soccer in the US, I want to do the first little demo here working with containers, and this is going to be one of the applications that you're going to join me in taking to Kubernetes. So I built this, I vibed this the other day. And let me go ahead and show you how this works. So let me hop into this application, this Dev Barcelona demo. And hopefully you can see this here, that just a second ago, I ran a Podman run. So similar to a Docker run, I would just do a Podman instead. And I'll talk about how this is different. But at the end of the day, we've got a backend with Fast API, and we've got a front end with React. And I'm going to open this up here so that we can see this little application running. Let me see if the music works. Hopefully you can hear we have some background noise on my computer. Okay, how many people here are Spanish? Uh-oh, okay. What's going to happen is we're essentially going to take this from our local machine to Kubernetes, and you're going to be able to scan a QR code to vote. For now, just raise your hand if you're on Team Barca. Okay. All right, so I'll throw some votes in. Anyone Real Madrid? Okay. Okay, yeah, see you guys. All right. So we'll have some fun with this today, and we're also going to add in some narration capabilities with models running in containers as well. So this is our little demo application, and we're going to have a fun time with this today. And I kind of built this to illustrate, hey, we have an application that we're working on locally, right? Whether we're working in VS Code or whatever it is our IDE is, we're essentially able to use Podman as an open source engine and Podman Desktop to take this as a container image, to put this in YAML and be able to deploy this in a Kubernetes environment. And we're going to make it very simple by doing all of this with open source and doing it all local today. So if you'd like to check out the slides, they'll be posted on Sessionize. But we also have kind of the slides here if you'd like to view it on Google Slides. And we're going to talk about, hey, yes, there is a possibility of running containers without Docker, and why would you do so? But we're also going to talk about the challenges in moving cloud native. I have a lot of experience working in Kubernetes, specifically OpenShift, and the ecosystem around that. And I will say that there are adoption challenges, but we're going to talk about how to make that easier as a developer and bridge the local to production kind of adoption barrier. So just a quick introduction. Hey, good to see you guys. My name is Cedric, and I am a developer advocate and open source engineer at Red Hat. That's my fedora because people ask me where the fedora is all the time. But it doesn't fit in the suitcase, unfortunately. I am from New York, so we have a Kubernetes community day there that I organize, and it's a great time. Highly encourage you guys to check it out. And I get to kind of create content and education around cloud native and open source. So if you go on YouTube, I do a lot of videos there, and I create workshops so that people can see, hey, there's open source technologies out there that you can use, adopt, and use in production. Now, when we're talking about production, as application developers, I'm sure many of us here are, we don't just write code, right? That's a small part of the process. But when we think about the inner loop and the outer loop when we're actually building applications, it's not just coding, but say building those applications to be able to debug, to test, and to push those commits into some repository where we, again, build and check for security and compliance before deploying with GitOps. And so there's a lot of people that are involved in this process, right, in order to deploy on Linux as a virtual machine or Kubernetes. But the thing is, this build stage is something that has been innovating recently. So, for example, I'll talk about, for the sake of, seeing how many people are here who have used it, I'll talk about Cursor, right? How many people have been using Cursor before? Awesome, cool. So if you use Cursor, like these AI IDEs, right, you're being able to output a lot more test cases, for example, or to remediate or make it easier to create a README. So stuff like that, practical things that we're, taking time that we can now automate. And so with this build stage here, what I want to talk about is, how can we prepare our applications to be better suited for Kubernetes, right? So you might have heard the news that Docker, for example, changed some of their licensing. So instead of $15 a month, for example, or $9, it's $15 per user per month, right? If you're an enterprise user of Docker. Or maybe you're trying to pull your image from a registry and you're hitting these Docker rate limits and you're like, why is this happening, right? So there's a lot of news that has been happening, especially in the open source community. People are asking, hey, is there an alternative to using Docker as a command tool, for containers? And there is, yes, and it's called Podman. So maybe you were impacted by those licensing changes, or you're in a large organization that can't run containers as root. Or perhaps you don't need full Kubernetes, but you want to run containers in production. Or maybe you do want to learn about Kubernetes and want to run these without having a cluster set up. There's a lot of other advantages here, but a reason I really care about Podman and Podman Desktop is having an open source tool so that all of us in this room can create issues and PRs and add new features to something that we use every day. So before I actually get into some of the demos here, Podman, if you haven't heard of it before, you can check it out at podman.io, is newly a CNCF project. So it allows you to do all the kind of similar functionality of building, running, and working with containers, but it does it a little differently. So this big difference is specifically in being a daemonless architecture. So instead of working with a background daemon in a client-server type of approach, where you have a client, which would be the Docker CLI or Docker Desktop, talking to a background daemon to pull images or run those containers, what's actually happening is Podman, as a process, is forking itself. That child process then becomes the container. And because of this, we're allowed to run containers in a rootless fashion. And at the same time, I'll show you how this works in a second, but the user namespaces are mapped in a way that if an attacker was to get into this container, right, they would only have access to this non-root user. So it really minimizes this attack space. And it's open source by default. There's no vendor lock-in. It's compatible with OCI and Docker Compose, for example. And if you want to see it in action, as we'll be seeing, you can just try it out using the tool for Mac or Windows or Linux, but it allows us to also work with Kubernetes. Now, just a little level set here. For just some terminology, images for containers are the packages that bring together the code and the dependencies and what this application needs to start in one single unit. It's essentially just a tarball with some JSON. But Podman has the ability to work with these, to build them and push them, and to run them as a container. So a container is that running instance of our application's image. So it shares resources with the host as well as the kernel. And once we have that container running, what we can do with Podman, and this is where the name pod specifically comes into play, is Pod Manager. So we can take those containers, directly translate them to a pod, and then be able to, say, move that to Kubernetes, all from our local environment. Now, the big difference here is, again, that architecture. So if you're working with Podman, what's happening is you're forking itself as a process. It uses a utility called conmon in order to reclaim the resources when you stop that container. And then you're using your runtime like runc in order to spawn the resources to run your application, right? By default, in a rootful context, which is what Docker uses by nature, is you're working in a rootless context for the CLI or Docker Desktop. But all of these calls and this fork exec at the end of the day is being done in a rootful context. So that's kind of a little bit of how it works. Docker also has a rootless mode, but it changes some conditions. But I would look into that if you're interested as well. So really quickly, I want to talk about privileged containers. So what's happening here is specifically with Podman. So let's say we're on the host namespace. This could be my laptop right here. I have my root user, which is user 0, but I also have all the non-root users. And what we're going to do, and let me bring up something here to help me with this demo. But what we're going to do is spawn a container, and I'm going to show you how this actually works with this namespace mapping. So let me go over here, and I'm going to give you a sneak peek of Podman Desktop, and I was just getting some things ready. But here I have a Podman machine. So I'm on Mac, and by default, containers are Linux, right? So I'm going to go over here to this terminal. So what we have running on my machine is a virtual machine for Fedora CoreOS. And what I'll do here is actually just do a podman run in detached mode, simple container, right? HTTPD. Access is denied. Oh, yeah, there we go. Live demos. All right, so we've got this container running. I'll just check the current, active containers. What I'm going to do here is actually do a podman inspect. So I'm going to format the information I'm going to get back, and here we're going to call the process identification number. So let me do that again. Process identification number, and then we're going to close this. All right. Oh, and I also need to call the name. So the name it generated for us is going to, well, we'll just call the container ID. So that's the process identification number that's running on Linux. And I'll talk about how this relates to, say, Kubernetes in a second. But what we're actually going to do is call and we'll copy this in here, but the specific user identification number and the mapping of this. So on my local host on this virtual machine, we're running in a non-root user. The container, though, is running, a root user, and the container is running 501 as a non-root user. So this is really interesting to see that, hey, these containers are running in a rootless fashion. If an attacker was to gain access, they only have access to that non-root user. And so that's kind of just a simple way of how Podman kind of enables more security when you're working with containers in a Linux fashion. If you want to learn more, I highly recommend some videos here that you can check out in the slides. This guy on the left looks like me, and he's a great speaker as well, so I encourage checking that out. But you can learn about how the container engines are different. And the rest of this presentation is going to talk about not just containers, but how you can take this to Kubernetes. So let's say, for example, there's some other features for Compose, so you can run those multi-container applications. You can bind the Docker socket. So let's say you have some build tools that use Docker, and you can bind that compatibility with Podman. And you can also run these, for example, as a Linux administrator so that every time your machine boots, you have these containers running. So this is a systemd unit file. So this is kind of what's used by systemd in order to mount your disks, to set up different boot activities. And so you can also run containers at the same time, which is really cool. As I mentioned, though, containers are cool. What about Kubernetes? How many of us here are working with Kubernetes or adopting it at the moment? Okay, fantastic. I'm curious, are there any pain points that you're currently experiencing as a developer, maybe, that you'd be happy to share? Is anyone struggling to generate YAML, or maybe they're in production and they're starting to kind of think about how do we replicate this in a developer environment, anything like that? No worries, no worries. I'll kind of explain why I asked that, because a lot of developer environments are kind of struggling from this big problem of moving between local and production environments where we actually deploy our applications, right? And a big cause of this is because how applications communicate. And I'll show this in the demo when we're actually connecting a database to our front end. But there's a kind of difference in how these containers talk to each other when we're working in a local environment and when we're working in Kubernetes. For example, I might be using Compose, which is much easier to use locally, right? But when I actually want to bring this to Kubernetes, I have to translate this file. And that's a little bit of work for our ops team to do, right? There's also a skills gap in understanding how these resources work, from deployments to services to pods, et cetera. And there's a big disconnect between those two sides. And specifically, this is what I call the adoption barrier, right? Where we have on the left the developers, which might be using, again, Docker Compose, base images that they've seen from Docker Hub, and there's no binding with these managed services that we're using, to then taking their .jar or whatever their application is and moving that over to the ops team where they have to work with their curated base images, right? That might have special dependencies or configurations, policies, and working in Kubernetes YAML. So for teams that are looking to go and move to Kubernetes, this is a big adoption barrier in going from that local environment to cloud native, right? The idea with this open source project, right, is to take what there already is with the container engine and to add extensibility and features, right, to be able to spin up local Kubernetes environments like Minikube or Kind, and to be able to deploy directly to a Kubernetes cluster, right? With Docker, what's happening is you're kind of creating your own individual environment, but with Podman Desktop, what you'll be able to see is that it pulls directly from your kube config so that you have those environments ready, and there's a UI in order to explore that. So we're gonna have fun taking this application and moving it with Podman Desktop. So Podman Desktop is this GUI interface, and the way I like to describe it is kind of the CLI versus the GUI experience. So show of hands, how many of us prefer Vim or Emacs or Neo or something like that as a code editor? Okay, see you guys. How many of us prefer using, Eclipse, VS Code, IntelliJ? Okay, sweet. So, you can use both. That's the good part, right? Of if you want a CLI or a GUI experience. For me, it's really helpful to not have to remember all of the commands and arguments and parameters when I'm running containers or when I'm building, and et cetera, et cetera. So we'll see how this works. But the idea is that it's free, it's open, and it's extensible by default. So you can work with extensions, you can build them, and you can kind of create whatever kind of a container engine you want, building on what we have already donated to the CNCF as a sandbox project. So there's open governance, and there's no worries about changing the licensing, anything like that. So without further ado, let's go ahead and check it out. I kind of gave you a sneak peek earlier into what Podman Desktop looks like. But here's the landing page, right? And so I'll show you the repository here just for a second. So if you want to check it out, GitHub, Podman Desktop, and same with the Podman project itself. Feel free to give a star. But let's actually hop over to Podman Desktop itself. And from the beginning, right, you have the ability to work with containers and images and pods, but also Kubernetes. So we'll explain how this works in a second. But a big issue is, as a developer, I want to be able to understand what I have running, or ops, what is running, be able to configure it in real time, be able to move from different staging environments and namespaces. And so this is kind of this all-in-one dashboard in order to understand, hey, what's exactly happening in my cluster? At the beginning, though, is this virtual machine for Podman, right? I showed you how it runs these containers as rootless, which is really cool. But it also provides the ability to install kubectl or Minikube or Kind, or work with these different kube contexts, so that as a if you're working with the different environments, I can select these and connect to these on demand and spin up new local environments when I need to. Okay, so let me come back over here, and what I'll show you is we've got a lot of different containers that I've been running and demoing today. So specifically, I'll sort these by which one is the newest. And we can see that I've got Kind, so I'll show you how that actually works here in a second. But I've also got that demo that we spun up in VS Code, so this demo right here. So I'm going to shut this out, and for the rest of the talk, we'll actually be seeing how Podman Desktop works. So when I come over here, I can build these images. So I've already done this in advance, but this is building for specific platforms or adding in arguments, et cetera, connecting to my registry there. So when I go ahead and actually start this as a container, well, we see first off you can inspect the layers or the information of the actual image, or say we can do a security scan, and I'll go ahead and skip through that here. But we're going to call this again DevBcn, and there's a lot of configuration here for, hey, do I want to add specific parameters, a restart policy if my application fails, extra host or DNS, and maybe setcomp profiles. All of these configurations that Podman provides now is in this interface here, so we can just start a container. So again, we've got our application running. It restarted, right? So we killed the container, and since we're not using a database, right, containers are ephemeral, so this application has been stopped. We got to start it again, and there we go. Our application's running. The thing is, we're typically used to working with containers like this all the time, right, as developers. And what we're going to do here is actually take this and turn it into a pod. So what I didn't show you earlier is that if I go over to this terminal page here, right, that you can see, is that we've got this Kubernetes YAML that's already prepared for us in order to, hey, drop this into a cluster or to, say, promote this to a local Kubernetes environment on my machine. So I'll show you how this works here. But first off, we're going to come back to that specific developer Barcelona container and create a pod with that. So we'll call this DevBcn pod, and we're going to expose that port that we had that we're using on localhost already. So you can see you have all my my previous demo pods to make sure everything was going to work here. But what we have running here is this in a pod. So we've got the infra container, and we've also got the actual podified version of our application. We can see it's running with UVcorn. And when I come back over here, let's go ahead and make sure it's working by just opening it up in the browser, and bam, the container was stopped as a container itself and restarted inside of this pod. And so we actually have, again, that pod definition in order to take this and deploy it to a cluster. The thing is, let's say that we don't have a cluster that we're already working with, but we want to experiment. So I'm going to show you two open source tools really quickly that allow you to do that. So the first is Minikube. Minikube is essentially running a single node of Kubernetes on your local machine. So this is a quick and easy way to get set up working with Kubernetes and be able to define, hey, I want to use Docker, or I want to use Podman, et cetera, et cetera. And what I'll be using for today's demo is Kind, so Kubernetes in a Docker container, or a Podman container if you like. And so this allows us to essentially set it up within a container running on Podman. So what's happening here is I'm creating an ingress. So on port 9090, we'll be able to expose applications. And in the background, we're pulling Kubernetes 1.31, preparing a node, and setting up this control plane so that we have it running as a container. So I'll give it a second here as it downloads. And drum roll. Sweet. So easy as that. We've created a new Kind cluster. We can see that in our kube config. And I'm going to come over here and show you specifically where it is. So we've got this running in a container. We've got kubectl. And all I have to do in order to promote this to a local Kubernetes environment is literally just deploy to Kubernetes. We've got that YAML here, and bam, I'm going to create that ingress. Boom. Easy as that. What's happening in the background is that it's automatically deploying, pushing this image to that Kubernetes environment, right? It's working with this YAML that we have created. It's applying that YAML, and it's saving me a lot of different a lot of time, to do this configuration, to create the YAML, to prepare it, to create the ingress. And so this is just in one click I'm able to do this, which is really nice. So we'll wait for that container to be created. And at the same time, I'll come over here, and let's go ahead and check out our control plane. So I'll do a kubectl get pods. And so we already have it running. And we could do describe or logs. Let's just check out the logs. So there we go. We've got our application running. The thing is, that's just one pod that's running, or one container that's running in a pod. Another example I want to show you is this kind of guestbook example. So over here, I've got a kind of, I've got a front end and a back end that's going to be a guest site. So our front end is essentially this Python app that's a simple connection to Redis, get a hit counter, and add that. Our backend is just going to be Redis. So we're just copying in with a multi-stage Docker file, Redis, and building that. So what's going to happen here is that we're going to essentially build both of these as I've done and push those so that we can start these up. So Redis here in the backend, I'll just give it a name, is going to be our cache so we can store those hits. Oh, Redis dev. So we've got that running here. And I'll go ahead and inspect this because what I want to do is kind of manually configure this and show you how traditionally this works with container networking, right? So dev, or Redis dev, right? So I've got this container running, I've got the IP address, and I'm also going to start up this front end. So we'll call this Python dev. And I'm going to append a host so that it can see exactly where Redis is so that when I start this, they've got that connection and I can start refreshing the page. So simple as that, we've built and ran these two containers. And just like what I did before, I'm going to go to both of these containers, podify them, and you're going to see that since they're in a pod, this is a Kubernetes resource where they're able to talk to each other in the same network and share the same resources. So let's call this dev python pod. And this is going to be created so that only the port that we need in order to access the application, which is that Python port, is going to be accessed. So this is really neat in order to kind of speed things up so that, hey, I have this Kubernetes manifest, including both of these containers, and I can take that, which is running locally, but let me just sort these by time. But I could also take this and deploy it again to our Kind cluster. So let's check that out here. And so this is a quick example of, hey, how can I take my containers, turn them into pods, and run them locally on Kubernetes? Now, you know, we had that game from the beginning, and I want to show you that game in a Kubernetes environment so that you guys can all try it and expose an ingress in a service. So I'm going to show you how that works here in a second once this container creates. Give it a second. We can check kind, and let's give it a second. Detail pods. All right. No. Okay. Pods. All right. They're all running. So good to go. This is where we could do testing. We could make sure that this environment is working for our containers how it should when we actually deploy it somewhere. And this creates that consistency as I talked about. So we've got a number of pods here, and what I'm going to do is show you a completely free environment that you can use for Kubernetes in order to develop and test your applications. Specifically, it's called this developer sandbox. So what it is a free 30-day, no information needed trial of OpenShift. So OpenShift is enterprise Kubernetes. It's our distribution of it, and so you get 14 gigabytes of RAM, which is pretty nice, and you can just renew it. But what I've done is I've already set this up. So I've got this environment here that I've already copied, the kubectl command in order to access it. There's no resources yet, but let's go ahead and change that. So I'm going to go ahead and move this over here, and we're going to come back over to the pods. So let's say I've done some testing in Kind, things are working, and this is really important at this stage, right, to understand that, hey, can I access everything in my application as it should be? Do I need to create some type of proxy or mess with the networking? But let's go ahead, and we're going to, first off, this dev python pod looks like it's still running. Let's go ahead and promote this to specifically this context here, this developer sandbox. And so I'll kind of refresh this, come back over here, and you're going to see now I have the ability to create a route by default using this specific Kubernetes YAML, right? So we've got both of the images here. We've got configuration for the port and the mapping that we want this to be on. And we've got this backend as well. So let's go ahead and deploy this. And you're going to see just like that, my remote cluster now has the Python pod, which is going to allow us to, fingers crossed, run our application as well as the Redis database in a pod on our Kubernetes environment. And we can go from there. The thing is, let's also go and try out our other application, which is going to be that game so that you guys can all try it. So let's come back over here, and in the meantime, before I do that, I'll show you what's happening is that, hey, we could, say, run a deployment locally on Podman or a pod, but now we can access that remote cluster, right, among others, to be able to actually see what's happening, all of the information streaming from our Kubernetes environment. We could even make changes. So let's say I make a change in the application. new port mapping or something like that. Or maybe I want to update to a new container image I pushed. I can just apply those changes instead of doing a kubectl apply. I can just do that locally here, which is awesome. So let me come back over here. That dev Barcelona pod, I'm going to deploy to Kubernetes as well. So this is the app with the game. So in a second here, I'm going to generate that QR code. I will also tell you that there's an API you can use to vote. So if anyone has, some spare time and energy, they can just spam it with like 1 million Barcelona votes. So here we have our game running. So the game running, we were able to test this locally as a pod, and now we have this running in a Kubernetes environment. What I'm also do here is come back here. I have a QR code generator in a container. So let me go ahead and run that. And I'm going to provide this URL, and let's see if it can stream in real time the votes you guys are going to do. So here is the QR code. Feel free to scan this with your phone, and then we'll see what the results are going to look like. And I have a feature for you as well that I'll show off, which is the narration. So I'll turn the audio on. Barcelona's up by 50 or 40. You guys are definitely doing some work on Barcelona or on Madrid. And I'll show you this narration feature in a second because that's also pretty cool. 260, okay. Yeah, so it's almost tied. But awesome, okay. So that's fun. This is just streaming with a WebSocket, just adding this to a Python dictionary. So it's, nothing crazy, but a little demo app I wanted to show you guys. Congrats to Barcelona. I'll give a couple too. No, I also like Madrid though, so, okay. Anyways, let's come back over here because I want to show you kind of the next stage. So let me open up this slide deck again and we'll go from here. Again, so this tool is free, open, and allows you to work with containers in Kubernetes. And it has a lot of tools to do so, as I mentioned, the integration there, but also using Docker desktop extensions. And behind the scenes, the setup is actually really cool. So the front end is Svelte and Tailwind, but the client that you're using is Electron so that we can deploy it for Windows, Mac, and Linux using this virtualization stack. So it's a really cool stack. And as I mentioned, we went to Kubernetes, but I have another extra demo that I want to show you because we have all the votes tallied, but it would be so cool if we had an announcer. So what does I mean by that? Well, we can use this new wave of AI and LLMs in order to add these cool features to our application. So there's an extension, as I mentioned, there's a lot of extensions with Podman Desktop for Minikube and Kind, but there's one for adopting AI. So this one is called the AI Lab, and it helps you with ideation and prototyping so you can test out models and integrate them as a container into your application. So this is really cool because it's all open source. So you're using models from Hugging Face, and you're just running them in a container. I know there was an analogy earlier to kind of Ollama and how it runs AI models as containers, but it actually doesn't run it in a container itself. Neither does Docker's version of this kind of model running behavior, but we run it in a container so that you could take it and also deploy it on Kubernetes. And there's a lot of reasons to do so, but I won't bore you with these slides. Let's go ahead and check it out. Because when I come back over to my application, what I'm going to show you is that the front end actually has a call to a model that might run locally. So I'm coming over to here to my React front end, and we can see that I've got this endpoint, which is going to be port 8008 for a completions API for this model that might run. And we're giving it a system prompt, also passing in the number of votes, which let's go back to the app and see how many votes you guys have done. I did not think there was going to be 800 votes. 1,200 votes. You guys are doing good. Okay, so let's come back over here. Wait. Where was I? Yeah, so AI and containers. So when we come over here, I've just kind of got this system prompt. It's like, hey, you're a sports commentator for this voting app. Always respond in English. There's a big change when it was lower caps and when it was fully capitalized for the results I would get. And then I say, you can include some slang. So I didn't understand any of the slang. I hope you guys will. And just passing in some other parameters, right? So we're just updating it every 15 seconds, or every 10 seconds, actually. And what I'll do is come back over here. So remember, we have our application running in a pod locally. So we've got, well, a couple versions of it, but we've got this Dev Barcelona pod, right, that we have locally. So again, if I was to do, a vote, you could see that post request. I'm going to come back over here to this AI lab. And the AI lab is really cool because instead of having to look for which model to use, I essentially just download it and I run it. So remember we were talking about port 8008? Well, I'll create a service on that specific port. Oh, I already have one running. Okay. So we'll use the one that's already there. And if I'm a developer, let's say, working with Python, maybe it's with LangChain, I have the code in order to integrate it there, which is nice. But the model's running. I'll just make sure it's running. Let's say, what's the capital of France? Spain. Sorry. That's the default, I promise. Okay, Madrid. Easy. There we go. Okay, so we'll come back over here to that pod, that Dev Barcelona pod. And remember, this isn't the one that's live, so I'm sorry. It doesn't have the 1,200 votes. Shout out to you guys for doing that. But we can kind of generate narrations based on the current score. So I don't know if you guys can read that. I will try to narrate it. Barcelona's onslaught. Oh gosh, it's going pretty fast. Hold on. Barcelona's crushing Real Madrid. The Catalans are on fire. El Clásico in the app is a total golazo for Barca. Is that right? Keep those votes coming. Hay que ganar. Woo! All right, we'll do one more. Que partido. The Catalans are on fire. The Blaugrana are crushing it with a commanding 70% of the votes. Obviously, my Spanish accent's really bad. But quick example of our applications running in containers and the model running in containers as well, which is really fun because we can actually take that and we can build all types of use cases. So for example, agents or RAG or all of these other types of applications like audio to text. And actually, this one's my favorite one. I'm going to show you it real quick if it'll build. Because what it allows us to do is use a audio to text model. So there was a presentation earlier on multimodal RAG, which is really cool to take in audio or to create audio and work with that. But I'll actually start this real quick and show you that, hey, you can use these open source models to translate, right? Which is really cool to build features for applications like, real-time, text to speech, like what they demoed at Google Cloud Next like a few weeks ago. So that was really cool. We'll give it a second here, and I'll come back over here because, we'll give it a second here. I can also show you that, let me go back one more time. 2,000. All right, 2,000 votes. Great job. And if you're interested, I'll show you really, really quickly that if you just hit this API, vote, you can just provide your tallies there. So if someone wants to go crazy on Postman, don't hit the reset. Don't hit the reset. That would be very bad for all of us. I'll check this one more time. We'll give it a second. But that's kind of a good demonstration of using the kind of AI models. I'll go back to this one for 1 second because what I want to show you is an example of, say, like a team cluster where we've got a lot of different moving parts. So I'm connecting to this cluster. And again, this is using kubeconfigs. So as I showed you, it loads your current ones and you can add new ones. And the specific one I want to show you is kind of this specific like lane graph demo. So we can see that, hey, we've got access to our deployments and we can kind of scale these as needed. So we've got that access there. The pods, the services, and for example, a route. So this is a quick demo I made for an agentic AI application. So this is something that could use multiple tools like DuckDuckGo or Python. We can ask maybe what's the weather in Barcelona. And so this is really cool because I built these locally on my machine and we're able to just push these to the cluster and now I have these running. And so the back end, what's happening is we're invoking a tool call with a model that's trained for, I need to pay for DuckDuckGo. but you understand the capabilities, right? But I was able to build these locally and then push them to a development cluster and access all of these other resources that I need to work with if I'm using Kubernetes. So the last thing I want to show is, it didn't start. So maybe we'll do it at the end, but this kind of, text-to-speech. But at the end of the day, it's all about working from our local developer environment, being able to use the CLI or use a GUI like this in order to build applications, to be able to test them out, make sure that they work in Kubernetes, and then be able to deploy them to wherever our applications live. So with that, I really, really appreciate you guys joining. I hope you had some fun with the game. Viva Barca, and thanks for coming. Feel free to rate the talk, and yeah, if you have any questions, happy to hang out.
Yeah, thanks. Yeah, okay. Thanks for the talk. It was really, really nice. I have a question. Like, you showed the capability of Postman. What do you use in development time? I mean, we have dev containers for VS Code, for setting an example, but is there some Podman containers, something like that?
Yeah. So you can use Podman as a engine for working with dev containers, but when you're actually doing the building process, the running and the pushing to your registry or to Kubernetes, that's where Podman comes in, and that's where like the real strength is. Because you could use it for your, IDE, and there's an extension for that as well. But the real value is, hey, I have this app that I've built locally. I want to test it, and I want to work with it in Kubernetes. It's one tool that encapsulates everything to do that, But yeah, dev containers is also, a good technology as well to not have to install everything. But Podman is that next stage of, hey, I've built that code, built the features, I want to take this and move it somewhere else, But yeah, that's a good question.
Hi. With Podman, you can use or you can test different architectures, maybe emulating that or something like that?
Yeah, that's a great question. So I was using a Mac here, and the nice thing about Mac is you have support for Rosetta with Podman. So let's say that I'm building for ARM64 or x86, an architecture that I'm going to use eventually down the line. What I was actually doing is emulating that on my machine. So if I come back over here, what's really cool is I can go to these images, and let's say that I have, well, I don't have the example here, but actually, so this specific image that I built here is for an x86 machine. That's how I was able to go from local to that Kubernetes environment that isn't ARM, right? Because of the emulation support for Macs. So that's a nice feature, to build for the correct environment. I could select both of these, could create a manifest, for example, but I was able to just build for these Intel or x86 machines, which is nice from the beginning. Yeah. Thank you. Oh, do we want to try the last demo? Okay. I've been waiting on this one. Okay. I need a volunteer. I'm sorry, but my Spanish is really bad. So does anyone want to volunteer to speak some Spanish and see if the model can recognize it? Catalan? Okay, I'll do it. Let's go to online voice recorder. I'll try to speak some French. My French is really bad, but I can't speak French. This is a Spanish conference. All right, I need a volunteer. All right, my friend, could you come up? Thank you. All right, what's your name? Mikalva? Ricardo. Okay, round of applause for Ricardo. Okay, you can say anything. You can say anything.
You sure? You will not understand it.
I definitely won't understand it.
Hola a todos, bienvenidos a la DevConf. Espero que lo estéis pasando muy bien. Y nada, que muchas gracias por la charla y que ha sido de mucha ayuda y hemos aprendido mucho.
Hey, gracias. Thank you.
That's it?
That's it.
Shall I go back?
It wasn't anything bad, right? Yeah, you can stay up here. Check it out.
Oh, okay.
Okay, so let's save it. Throw it in here. It's all running in containers, so it should be pretty fast locally. And we'll give it a second.
I didn't say anything. I didn't say that.
It did not work. It just says speaking Spanish. I'm sorry.
Maybe it's my accent. You
No,
know?
no. AI is not taking anyone's job. That's what we learned. Thank you again. Gracias, Ricardo. Yeah, that's, fun example. If we actually go in here, you can actually see, hey, we've got the model running, and we've got that's the error it did. All right. But, quick example of, hey, you can build these applications. You can build them with models however you want and deploy them anywhere. And, yeah, that's the talk. So I appreciate it. This was really fun. Huh? Oh, yeah, let's go back. Oh, no, did it go? Hold on. I can upload it again if you want to see, but it definitely didn't do a good job. Let's come over here. It's using Whisper, which is a model from OpenAI, one of the few open AI models. And yeah. Of course. Yeah, appreciate it, guys. Sweet. And if anyone wants the slides, again, I'll kind of come up here. And yeah, feel free. Sweet. Thank you, guys.